Okay, so normally any Python program is executed, so collection of instructions, right, is executed in a sequential fashion. So if we go and write, my bad, let me just add the cell here. Demonstration purposes, A is equal to 1, then B is equal to 5, then C is equal to A plus 1, D is equal to A plus B plus C, and we print D. We can also check the order in which everything got executed. This is a standard of an imperative programming languages. Not all programming languages function the same, right? As in statements getting executed line by line. Print B, print C here, and then print D. And now we should get a list of prints like 1, 5, 6, and then 6 plus 5, 11, plus 1, 12, something like that. Well, I'm bad with arithmetic, told you. But still, 1, 5, you can see that this statement got executed in this one, then this other one, and so on and so forth. Sometimes you want to break this execution. You can do branching. For that, you can use the if then else statement, branching. And sometimes you want one line to get executed multiple times. For that you use loops, like for and while. Loops. Okay, let's look at the branching situation. We'll go A is equal to 25, and we can consider if let's invent something. Let's say if let's put a number in here. If the number is greater than is equal to 0, smaller than 0, we want to print out negative. If otherwise, so if the number is equal to 0, we want to print 0. And else, so basically if the number is greater than 0, then we print positive. Of course, I want to print these things, right? Not just have a string in there. Sorry. Print. And here, print. Okay. And now for a number equal to 25, I will separate these cells just for the fun of it. Okay, number is 25, and now we should get positive right here. Change this number to negative, -1, we should get negative. And change it to 0 as a float, and we'll get 0. 0 as an integer. Of course, I need to freaking execute this. Oh, my bad. 0.0, that should be the same thing. There we go. So in this case, we didn't get the execution starting line by line. We didn't execute this line first, then this one, this line after, and then this one, and so on and so forth. Instead, this was like follows. So first condition is checked, the line where the if is defined. Num is not smaller than 0. Okay, because this happened, the Python jumps to the next condition, else if. Else if number is equal to 0. This was true, so we printed 0. And the positive, the lines inside the conditions, basically are ignored. Note that you have a condition on the one hand, and the statement that gets executed if that condition evaluates to true, right? To distinguish between condition and block of code that gets executed if that condition is true, print hooray. Okay, and print meh. And for some reason we're happy for negative numbers and sad for positive ones. Sad. Okay, so to distinguish between the condition and the block of code that gets executed inside, if that condition evaluates it true, we use indentation. So you can do that by pressing tab in here, and when you press enter after a line, you will already be placed in the correct indentation. Basically, the block indented like so will get executed. If I put this print here, we'll have a different behavior. Let's not for a second. So number is equal to 0, so we'll get 0 and meh right here. If I de-indent this, I should get an error because Python knows that all conditions have ended when it sees this else block, right? So right here, everything that we have before the else should be in the indented block like so. Like so, we'll have an error, syntax error, right? So always indent condition and then indentation block for everything that gets executed if that condition is true, right? We can change the indentation here. Let's make it sad. So let's give it a positive number, 23. Sad. Okay. If we change the indentation here, that will be legitimate and sad will get executed. We get the same thing. But now if we have a happy number, we'll get hooray and sad. So -1. Hooray gets printed. Why? Because this condition evaluated it true. We jumped in, we evaluated this, executed this line of code, the next one, and then we skipped all the other conditions because these are exclusive. If this condition is true, the other ones cannot be true. If this condition is true, the other ones cannot. And we got the happy situation, negative hooray, and then sad because of the indentation block. If I put it back, then we won't get the sad block. There we go. This I already discussed, casting other types into booleans. You can use this for the conditions, right? So any condition has to evaluate to a boolean here. I will skip that. And now you can also nest loops. So I'll just copy everything here and distinguish between odd and even negative numbers. Let's say here, if number modulo 2 is equal to 0, so it's an even number, we will print even hooray. Again, the indentation thing applies, right? Negative even hooray. I want to execute that code whenever the thing is negative, and here I'll just put an else. You can have as many ifs as you want, but only on else. The else delimits the end of the branching statements. We'll print an odd hooray. Odd hooray. And I don't like odd numbers that much. Even are nicer. Odds just get a straight face. So we have a -1, that's an odd hooray. So we'll get negative odd hooray right here. There we go. And you can nest as many branching statements as you want. Okay, let's go and talk about the loops.